Are we
All
live?
right. Hello, everybody. I hope the microphone is working because OBS is working a little bit against me. Thank you all for the second episode of Nomad Under the Hood. And we have a special theme today. We're actually going to be live coding together with Seth. Seth, maybe you can introduce yourself and explain what you're going to show us.
Yeah, so I'm Seth. I'm a engineer on the Nomad team. Been there for almost coming up on a year now, actually, which is hard to believe. uh, in that time, I've been working on a lot of the Consul Connect integration between Nomad and Consul. Um, One of the things I've been working on lately is adding support for Connect Native. Uh, so Consul Connect, if you're familiar, is like the HashiCorp interpretation of service mesh, right? So you have your console service, you declare services in console, and then through Consul Connect, you can have those services communicate between one another securely with all the authorization, authentication, like MTLS certificates, all that kind of stuff. Just kind of built in and automatically generated and configured for you. And so Connect Native, what we're doing today is basically Consul Connect, but without the need for mesh gateways, aka Envoy sidecars, right? So
So,
I'm sure you're all. Go
question
ahead.
about that, right?
Mm-hmm.
So I think a lot of the people viewing today are familiar with using service mesh with the sidecars. What are some of the benefits and some of like the downfalls of using native versus sidecar proxies? Are there things I'm going to lose by going native?
Yep. Okay. So Connect Native is, I mean, it's a real product, part of Consul, but it hasn't gotten quite the attention of the mesh gateway side of the Connect story. Um, so what Native does bring for you is, first and foremost, in my opinion, is just simplicity. Configuration is easier when you're only thinking about your application
Okay.
as opposed to your application plus this sidecar. Um, Another thing that it brings for you, kind of at the extreme end, is performance. Envoy is fast, but nothing is going to be faster than not having an extra network hop and extra like HTTP body parsing and all that stuff. Um, so Connect Native is we kind of, I would say, target it, or like we intend for this to be used by the more advanced users, uh, because some of the downfalls are that it does require changes to your application. Not huge changes. So if you're familiar with like Go's HTTP client library, you create a HTTP.client, whatever, and then you do stuff with it. Well, it's kind of similar to here, except there's a first-class Go library where you can like create this service object and create an HTTP client from that service object.
Okay.
Uh, and that special client will know how to do a lot of the connect things. And we'll actually take a look at that in a second. Um,
Do I
some other
get?
trade. Oh,
Oh,
sorry. Go
no,
ahead.
no. So do I get some of the benefits that I would normally get with Envoy as well, like reconnections, load balancing, and those
Yeah.
kind of things?
So it's a mixed bag. You get some of like console DNS. You get those features without actually configuring console DNS,
Nice.
but you don't get some of the features like um, expose paths. So with a Envoy gateway, you have like your application is now inside a network namespace and has like a normal HTTP endpoint that needs to be reached from other services, like console checks, for example. Um, with the Envoy gateway, there's a feature where you can expose that like just plain HTTP path, like a specific HTTP path,
Yeah.
to make it possible to do health checks and stuff. But with Connect Native, that feature doesn't exist, for example.
Okay.
So it's not one-to-one feature parity, um, but hopefully with time, maybe that'll happen. I don't know.
So it's
Uh,
basically like a trade-off where you get extra performance, simplicity, but right now you don't get all
yeah,
of
yeah,
the features yet.
yeah. Basically, console team is really focused on the mesh gateway version.
Okay.
Because it just happens to be where all the services in the world are written like with plain HTTP, and we want to onboard them into the service mesh story. And so that's where the focus has been.
Okay.
Yep.
So
So
where
yeah,
do we get started?
we get started. So anyone who's like used Nomad with Connect is probably familiar with Count Dash. It is like
Yes.
the kind of just canonical example for running Connect-enabled services. We use it both for documentation purposes. We use it for end-to-end testing purposes, and we use it for just like local development purposes. Like if I can make this feature that I'm adding work with Count Dash, then it's a reasonable assumption that's going to work generically with other services that one use Connect. And to that end, instead of Count Dash itself is like not Connect native. So I created a new example, little toy example here, that is vaguely similar to the Count Dash example, but instead of counting hits to your front end or whatever, this one is just going to generate some UUIDs.
Okay.
But it's two services still. There's an API generator backend service that actually generates the UUID, and then there's a front end kind of HTTP service that's going to talk to the backend to get the UUID and present it as HTML to the front end.
Okay.
So fairly straightforward.
What do they currently talk to each other? Is it still WebSockets like the original Count Dash?
No. It's so the communication here is happening through the Connect native HTTP libraries.
Okay.
So the API generator, in fact, let's just jump into that.
Yeah.
API generator service here.
Can you zoom in a little bit?
Yes, I can.
Thank you.
So this is the generator service. And this is kind of the special line that I want to point out. So this Connect is using the Consul Connect library to create a new service, Connect service. And then that service is being used in this kind of constructor for the HTTP server, just
Okay.
like regular Golang HTTP server. But it's doing something special here, which is using server TLS config from this Connect service object. And this little special TLS config is the thing that does all of the TLS magic under the hood, right? And so when you look at this listen and serve TLS, you can see I'm passing in blank and blank. And normally this would be like your address and your, I think, cert files or something. And we don't pass anything in here because this runs a background Go routine that's going to manage that stuff for us by communicating with Consul.
Okay.
And like getting all that information and setting it in place just automatically.
So Consul is basically creating the identity for this service, passing it back, and then we can use this new constructor to actually create the TLS config from that identity, basically.
Yep.
Nice.
So all that's just kind of taken care of magically by Consul now. And then on the front end side, let's go here. You have something kind of similar, but instead of an HTTP server, we care about the HTTP client.
Yep.
So we, again, create a new service object, a Connect service object. And then for this HTTP handler, we're not doing anything special, except we're passing in the HTTP client derived from this Connect service.
Okay, so that'll generate a client for us with the correct client certificates and things like that.
Yep. And it knows how to refresh that certificate in the background using Consul and all that stuff.
So does it use the XDS then in Consul the way Envoy does to automatically refresh information from the environment, or?
No. So XDS is, I don't want to say specific to Envoy, but it's very tied in with the Envoy project itself.
Okay.
The way Consul implemented this, to the best of my knowledge, is just through regular HTTP.
Okay.
So there are just plain HTTP endpoints you can use to communicate with Consul to do all this stuff. So if you want to implement your own Connect native library, like you can do that, and it's not that difficult.
Okay.
The only difficult thing I would say is that background thread, I guess, in other languages that needs to refresh the MTLS certificates. And even that's not that terribly difficult. It's just got to manage locking and all that stuff. But you can do that.
So if somebody wanted to, they could easily implement this in another language.
I think it's reasonably straightforward, yes.
Okay, cool.
But HashiCorp only provides the Go library for now. Okay, so I want to run this example without Nomad first, just to get an idea of what we're actually doing, or what Connect Native looks like. And to do that, let's take a look at this services.html file. So I just have two services that I'm going to define, UID API and UID FE for front end. They're both Connect Native, you can see, and they both have a port. Since we're not using Nomad, we're using static port definitions here.
Yep.
Okay, so I'll go ahead and launch this. Console is running.
So they'll just directly talk from port 2001 to 2002. Those will be...
Yeah. So I need to be... Okay, so I'm going to launch the API backend, and I just printed out all these like console environment variables because we're going to use these later.
Okay, I'm getting the request for a slightly bigger font size by James.
Yeah, okay. Is this bigger, better? I can make it bigger.
Yeah, just make it one tad bigger.
Okay.
Yeah, oh, that should be enough.
Jumbo mode.
Otherwise, James needs to zoom.
So now, okay. And so now I'm going to run the front end half of this.
Yep.
Passing in this environment variable. So this environment variable is just specific to like my little toy example.
Okay.
It's not part of the console library or anything. And what this environment variable is used for is part of the console DNS name that we're going to use.
So with this this name, right, where you're defining the upstream, which is like very similar like you would do with Nomad Connect integration with Envoy, etc. Does it then fetch the port from console itself, and you don't have to specify a local port because there's no proxy, obviously?
Exactly.
Okay.
I'm trying to find exactly where that happens. If I can remember anything. Oh, I think it was where I just was. Or it might be in here.
Get UID upstream.
Here it is. Yeah. So this is the console DNS name that we're using.
Okay.
So I don't have to think about ports. I don't have to think about IP addresses. I don't have to think about my own network, right? I only care about the way console sees this thing, which is with this very easy name. And this %s is just this environment variable.
Yeah, so that would work the same for nodes then. I could do node name node.console as well, I assume?
I believe so. Yeah.
Okay.
Okay, so I'm going to run this. Running on 2002 localhost. And so if I pop over here, and I go to localhost 2002, hey, it works.
Okay.
I get UIDs. Not that interesting, but it's just a trivial example that kind of highlights like the important bits, right? And that's the whole point.
So just out of curiosity, I'm assuming you're having console running locally.
Yes.
Could we take a look at the UI just to see, like, I'm assuming they just register as services like they would normally?
Yeah. So I have, if you remember, I'll go ahead and shut this down. Just these services.htcl file, right?
Yep.
Just these two services, that's all I've got.
Okay.
And they show up here.
And do I get an indication in the console UI that it is a Connect Native, like you do when it has like a sidecar proxy?
That's a It's a good question. I don't think you do actually at the moment.
Okay.
Probably something that can be added pretty easily. Okay, so enough of that example. Let's do the same thing, but with Nomad, right?
Yep.
So I've got another window. Try to make this font bigger, this font bigger, this font bigger, this font bigger. Sorry, a lot of stuff. Okay, so here I've got Nomad. Here I've got some examples that I'm going to go into. This run console run Nomad. These are really trivial. They just run the thing with some parameters that make life a little easier.
Yep.
So let's start with what actually we know works, which is running Connect Native tasks in Nomad with host networking. Right. So this is the
that would
case
be the
for
same as you did before, just Nomad
Yeah.
running the binaries.
Yeah. And so just looking at this job file, here's my API backend, here's my front end. Native equals true, native equals true. The front end has a static port because, just my brain, I want to know where to go. But the back end, we're going to let Nomad choose the port.
So
we just don't.
What I just noticed is, and something I haven't used yet, is connect native equals true. So that is the magic sauce to change it, the mode from sidecar to native?
Yep. So this is new in Nomad 0.12.
Okay.
Native equals true. This informs this task group that the task is Connect Native. If there's only one task, it's derived. It just kind of knows automatically, like, oh, it can only be this one task.
Yeah.
If you have more than one task in a Connect Native service, then you'd go into the service definition and just indicate which task it's for.
Okay, so then you're basically pinning a service to a specific task.
Yeah.
Okay.
But if you only have one task, then it's just automatic. Okay. And so we've got our Docker image of the thing we were just running before.
Yeah.
Same thing down here at the front end. It's got the same upstream environment variable. You'll notice these things are binding to 0.0.0 public. So anything will be able to connect to these things, which is not quite what we want, especially for this backend service. But that's kind of the trade-off of host networking, right?
Yeah.
You're just going to have to live with.
It's simple, but there's downfalls.
Yeah. And of course, just for the port, we're passing in, this is Nomad special syntax for just give me the dynamic port that Nomad allocated, right?
Yeah.
Okay, so nothing terribly special here, just native equals true. Let's go ahead and run
console. In the Nomad file, I noticed that one of the ports was dynamic and the other one was static. That's probably because then you can browse to that.
Yeah, exactly. Just for my own brain, like just to navigate real easily.
Okay.
Normally, you might have something like traffic or some other front-end load balancer that reverse proxies in, and blah, blah, blah.
Yeah.
We'll talk about more at the end if we have time, because that's actually quite an interesting topic that I'm going to be working on next.
Okay.
So here, let's run Nomad. This will take just a second.
So with the native integration, you don't need to enable anything special on the Nomad server or the Nomad client. There's no plugin.
All the normal Connect stuff is exactly what you need. Yeah. Okay, Nomad running. Nomad job status. Nothing is running. Let's run cn host.nomad. Job status in hosts. Okay, my Alex down here. They're running.
Looks good.
So in theory, if we go to our port 9800, it should work, and it doesn't. Why doesn't it work? Probably because I. Why doesn't it work actually? See, network mode hosts 9800. May have just been warming up. Nope. All right.
Maybe check out the allocation.
Yeah, let's do live debugging.
That's always good. I always enjoy live debugging.
Absolutely. EE7. Okay. This guy. Wonder if it'll work if I do that. Yeah, sorry. Nomad 2.12 introduced some new networking stuff, and the localhost cheat that we all love kind of broke a little bit.
Okay.
So I have to like actually specify my IP address. So anyway, it does work. Host networking. This is my local area network address, and so that's cool, but not unexpected, right? Host networking was going to work anyway.
So I was hoping so.
Yeah. So let's go ahead and stop our host networking version.
Because this has all been like very straightforward, right? This has been what we expected. Yeah. But obviously with host networking, you get a huge pitfall, which is security.
Right. So that backend service, like, it's kind of exposed to the whole network, right?
Yeah.
It's, above and beyond. I mean, it's still protected by the MTLS certs of the service mesh, but you're still, like, you can have people try to connect to you and like try timeout attacks or whatever. It's better to run things inside a network namespace.
Yeah. Well, I guess that's one of the advantages of running Connect Native over the sidecar proxy is normally your application would be listening on localhost, right? And then basically everything from Envoy would be MTLS encrypted. With Connect Native, you can't just go to localhost and hit it without identity.
Exactly. In fact, Nomad doesn't let you use the normal sidecar connect without bridge networking, at least for now.
Oh,
because we don't want to accidentally have people like expose themselves thinking they're only on the mesh network.
So is that a change in 0.12 as well then?
No, it's always been that way.
Okay, because I remember using the Connect integration, but without the network namespaces before those were implemented.
Maybe if you plumbed it yourself a long time ago, then sure.
Oh yeah, if you're that for sure.
But if you're using Nomad's Connect integration, at least from 0.10 when it launched, it forces you to go into bridge networking mode for the allocation.
Okay, which is good because that makes it more secure, right? Because localhost for the application is then not localhost on your host machine.
Yep. Okay, so moving forward, here's the bridge networking version of running our Connect Native tasks. You can see the difference here. Network equals bridge.
Yep.
If I open up the old one, it was nothing, except down here in our Docker images we had network mode hosts.
Yep.
Over here in our Docker images we have nothing. So those just inherit the bridge mode of our allocation or a task group.
Okay.
And this is same thing down here for front end, and everything else is the same.
So a question about that, right? Because now you're using a dynamic port, but since you're using bridge networking, you could use a static port for the API now as well, right? Because it would only be local to that namespace.
You could do that, yeah.
Okay.
So if we let's see, first of all, Nomad job status. So our other one is stopped. If we refresh this, it'll die. Nomad system DC, just clean things up. All right, let's run the bridge version. Okay, it appears to be running. Our Alex are up and running. Take a look. Everything looks fine. It even says healthy. So wait, we're done, right? Just go home. Everything's working.
Yep. Well, you would hope so.
Except no, this definitely doesn't work, right? And the reason is because our applications are not able to connect to Consul. And we can see that if we go look at the Docker logs. So we can verify we're in kind of bridge networking mode by looking at the fact that Nomad created these pause containers for us.
Yep.
And of course, just like in Kubernetes, these are used as kind of like a representative for the allocation to hang the network namespace C group off of. So in case if my actual application gets restarted or whatever, the network namespace doesn't just disappear.
Yep.
These pause containers, the only thing to do is exist for the life of the allocation and therefore the life of the bridge network. So we know that's working. So if we look at our containers, they're also up and running. So what's going on?
And I'm assuming that the services are actually registered in Consul because Nomad does that for us.
Yeah. I lost my window here. Where'd it go? I actually don't know where that went. This is the old one. Let me close out of that. Oh well. Classic GNOME bug here. I'll just create a new window. Sorry.
That's okay. If it doesn't work, just retry it.
Yep.
Oh, don't forget to make the size bigger.
Yeah, I'll do that in just a second. Connect native bridge. All right. So I'm going to go ahead and kill Nomad and Consul. So we can get back to the logs from here. Okay, let's do this again. We launch Consul.
Yep.
Launch Nomad. We run our bridge job again.
Okay.
All right.
That looks
and
good.
We're running again. So where were we? Docker. We've got our pod containers. We've got our task
jobs.
containers. Yep. So let's look at the logs for these. Here we go. So we got our environment variables that aren't set, and we've got these errors, right? So this connect library inside this alloc is trying to connect to Consul at localhost 8500 as the defaults all are.
Yeah.
But it can't because it's inside this inside this network namespace that is set up by Nomad. And so if we come back here,
and that's not listening on localhost, obviously.
Yeah, it's just nothing's happening. Okay, so we're gonna fix this, right? And the way we're gonna fix this is by having Nomad forward these requests basically onto Consul, bypassing the network namespace. And the way that's going to work is we're going to create a Unix socket.
Okay.
And we're going to mount that Unix socket inside the alloc file system namespace. So the service will be able to connect to that socket. That socket will be proxied by the Nomad agent, actually. And that Nomad agent will be connected to Consul, forwarding and passing traffic in between everything.
Okay. So for the job, it'll just be I'm talking to my local socket, which is just listing on my file system, and it won't know what happens after that. That Nomad forwards it, and
we'll see how that gets plumbed through.
Okay.
For those kind of playing along, this ticket actually describes a similar process without magic. So you can actually configure Consul manually to listen for a socket. You can configure Nomad to mount that socket into this allocation using host volumes.
Yeah.
And then you can configure this environment variable to point at that socket. And so we're basically just doing this more or less the same thing.
But you're trying to make it magical, basically.
Except we're going to make it magical.
Okay.
Okay.
Yeah, so
And I think
because
this,
for the console client, it doesn't matter if it's talking to a Unix socket or an actual network endpoint.
correct. So the Go library that HashiCorp provides knows how to talk over Unix sockets.
Okay.
And we're kind of leaning on that a little bit here, even though it's not difficult in other languages to implement. But yeah, we'll be able to just set this environment variable inside of our Nomad hook that's setting up the task.
Okay.
It'll
So you're
just work.
basically going to check like if we are in bridge networking, set this. Okay.
So let me stop this job real quick. Okay. And then we will start programming things. And so the way Nomad works, whenever it's launching something, so if you watch the previous Nomad Under the Hood, Michael talked a lot about the scheduler.
Yes.
And like, create a job, go through the job endpoint, schedule a job, and then later down the line, like your job runs some way, somehow. And the some way, somehow is like a whole other Nomad Under the Hood talk. But real quickly, there's at least two types of hooks that get run every time you launch something.
Yeah.
The first type being alloc runner hooks, and those are going to run on behalf of your entire task group.
Okay.
So if you have more than one task, you have a task group, your alloc runner gets run on behalf of them. And in our case, that alloc runner is going to it's going to establish the, many things, not the least of which is the network namespace, but also this, it's going to create this Unix socket for us. And so I've already filled out the boilerplate for what I'm going to do here. And the way I did that is just by looking at a very similar half of this, which is a socket hook for the Envoy proxy.
Okay. Yeah.
Right? Because Envoy, and it uses the same trick, right? But it's slightly different in that Envoy wants to go through, it uses XDS, which is based on gRPC, which is HTTP2 and all that.
Yeah.
So whenever you use Envoy sidecars, you have to have the gRPC port enabled on console for it to work.
Correct.
It's called
8502
gRPC protocol.
if I remember correctly.
Yep, 8502. And then, so instead of just reusing this, I created just a copy of the outline, and we're going to kind of look at this implementation and change what needs to be changed and implement the same thing, but for this HTTP listener.
Okay, nice. So this gets executed once per task group. Is that correct?
Yeah.
Okay. And in the case when you have that example of, well, it would obviously be the same. So the thing I was going to say was for the example where you have multiple tasks that are all Connect Native enabled and you're specifying the specific tasks, they would still all share the same console socket, obviously.
If they're all in the same task group, they're all calculated by the same network namespace, they'll all go through this one socket, and it'll all just work.
Okay.
We will also work on the task runner hook associated with this, which is going to set the environment variable.
For that specific
HTTP, task? Yeah, for that specific task.
Because that needs to get set on the Docker container.
Yeah, and that's a task runner hook thing.
Okay, cool.
So let's get started. Right off the bat, there's just some
I'm thinking for James, we probably need to zoom in.
Let me zoom in a little bit. Sorry.
Yeah, that's
I'm
perfect.
trying to use Golan's presentation mode for the first time ever, so bear with me.
It's going well so far.
So we have a hook name. This is just for logs and stuff. We have our little hook object that has our logger. It has a reference to the allocation, a reference to this proxy thing down here that's going to help us manage the actual connection proxy.
Okay.
We have basically a constructor that just kind of sets things up. And then we get down
this
here.
is all basically duplicated from the way the Envoy hook
was
implemented, right? So
if I line these up just right, you can kind of see I've copied and pasted a bunch of stuff and just renamed things.
Okay.
But then we get here to the actual implementation, where I just kind of deleted stuff, and where we're going to actually start implementing things.
Okay.
So should run. first and foremost, a hook doesn't always necessarily run. It might not even be registered, just kind of depending on some conditional logic before we even get into this.
Okay.
But even if a hook does get executed, it might not want to run. Maybe like it's designed to only be run once, for example.
Yeah.
In this case, should run. We're only going to run if the network is configured, the test group network is configured to be in bridge mode, right? So how do we do that?
A question on the should run, because I see pre-run, update, post-run.
Okay, yeah.
So these are all run evaluated for each of those, or just once?
No. So this is a private method. We're going to make use of should run in pre-run.
Yes,
and
I get it.
Update. Yeah. So these capital ones. These are exported. They implement the task runner interface. I forget the exact name, but you can like just click through this and like, my shortcuts are different in presentation mode. So this will be interesting.
But these are basically the public methods that'll actually get called, and the should run is basically
exactly. So if we look at this update method, so let's provide some context.
Yes.
The first thing we're going to do is lock this hook thing, assign the alloc reference so that we know what we're working with, and then we're going to detect whether or not we should run. And so that's what we're going to implement first here.
Yep.
Okay. And so actually should run is quite similar between these two, I suspect. In fact, this one could be improved upon now that I think about it. So we're going to get a reference to our task group represented by this task runner hook. And we're going to do what we said, right? We're going to make sure this is only going to run if we're configured for bridge networking.
Okay.
And the way we do that is we take a look at networks. Whenever you have a Connect enabled job, we only support one network defined in the allocation.
Okay.
So I can just cheat here and use networks.0.
So that'll get enforced when I try to submit the job. It'll complain if I have multiple defined.
Yeah. That's handled like in the validation step.
Nice.
And so if I take a look at the network mode for this allocation, it should be in bridge mode. Otherwise, we're not going to run, right?
Yep.
Pretty straightforward. In fact, I'm not going to do it now, but we'll probably add this to this should run as well, just for belt and suspenders safety.
Yeah, like you said before, you should.
It requires bridge mode, but in theory, that's handled or validated elsewhere. But it's always good to, defensive kind of programming.
Yep.
So the other thing we're going to do is, make sure we actually have a Connect native task in this allocation. Otherwise, there's no point, right? It's just very similar to this check we have here for the Envoy bootstrap hook, which is detecting if we have a sidecar. Oh, I even left myself a note here. That's fine. So very similar. We're going to loop through our services defined on the test group.
Yeah.
If we have a connect.is native, we are going to return true, right?
Yeah.
So we're just going to try to loop through each of our services, see if we have a connect native service, and return true if we do. Okay. And that'll be good enough for this to detect whether or not this hook should run.
Because if any of these services is Connect Native enabled, you want that socket mounted.
Yep. Okay. And so the thing that calls this hook, pre-run, and I guess update later. So this is the thing that actually gets run before any task gets launched.
Okay.
This pre-run interface implementation. And so what else is there to do in pre-run except detect if we should run, right? So if h.should run, we're just going to exit early, right?
Yep.
So if we're not a Connect native task, or if we're not in bridge networking, we're just not going to do anything.
Okay.
Just return nil, right? And then for otherwise we should run. We're going to come back to this. But we haven't implemented the proxy yet, so we're just gonna come back to this in a minute, right? And it's kind of a similar story for update, right? So update will.
So when does update get called?
Update runs anytime you make a change to the allocation job spec and rerun the job.
So that's basically when you changed your job spec, but it doesn't require a new allocation to be made. It can update in place. Is that correct?
So this is going to run, I want to say whether, like even on destructive updates. Okay. And in fact, right here, what makes this different from pre-run is that we're going to reassign the alloc associated with this hook, given the alloc passed in whenever this gets called.
Okay, because we will get an updated allocation from the hook.
Yep. Okay. And then similar down here, whenever we have a proxy to run, we're going to run it. Okay?
Yep. With you so far.
And then in post-run, I think there's really not a whole lot to do here except stop the proxy, which doesn't exist yet. Right?
So this is basically when the allocation gets stopped, this is the cleanup that we can do.
This is the cleanup hook, part of the hook, yeah.
Okay.
Okay, so before we do anything else with this stuff, it seems like we need an actual proxy to run. And so down here, we have the boilerplate that I already added for creating the proxy. And if we look over on the Envoy side, it's all, copied and pasted.
Yeah.
Right?
That's just so because you need the same information and you're pretty much doing something similar.
Yeah. And so a bunch of this is just going to be copied and pasted. Like this would normally take me a lot more than an hour to do.
If you had to figure out how to do everything and what needs to be done.
But this is already here. So I'm going to copy and paste things. So we can detect whether or not we should run, given that we're already running, right? We only need to launch one instance of this connection proxy per allocation.
Yeah, because you would probably get errors if you wouldn't, because the file's in use.
Yeah. And then this is just going to be some plumbing that I copy and paste. That's just like handling like the done channel to detect if it should stop and all that stuff.
Okay. Is that to cleanly shut down if we're stopping, etc.?
Yep. Okay. So I'll just add that in here. And here's where things are going to start to get a little bit different. Because we see like, oh, destination address is the gRPC address. Well, we're not using the gRPC address in the HTTP version, right?
Yep.
We're using the HTTP address. So instead of doing this kind of shenanigans with gRPC, let's just set dest address to the configured console address on the Nomad agent.
I just got a request from Schmeigel if you could increase it once. Schmeigel is getting a bit older, so we need to facilitate.
It's fine. I mean, Schmeigel wrote this in the first place, so
so
he should already know how it works. Okay, so just real quick, let's go ahead and check to make sure this dest adder is actually set. Just kind of out of defense and depth. It would be crazy to get this far without it being set, but I like safety.
Yes, better than getting a nil pointer somewhere further on.
Yeah. Okay. And so we basically just did all this in like one line because our version is simpler. So now we have this host gRPC socket path. What the heck is that? Well, this is basically just the mount point of the Unix socket that we're going to have inside the namespace.
Okay.
Right. So just taking a look at this, we have this alloc gRPC socket. Well, that's not quite what we want, right?
Yeah.
Let's take a look at this. Yeah. So we have this. This is the one that existed already, console grpc.sock.
Yeah.
And it looks like boilerplate. I just kind of already added a constant for the HTTP version of this. And the only difference, of course, being the name,
Yep.
HTTP.sock versus grpc. And that way, both of them can exist in the same allocation.
Oh, so you could actually have a task that uses Connect Native and another one that uses Envoy, say if you couldn't alter it.
Yep.
Oh, right, could you also zoom in the right side?
Yes. Is that better?
One more? Yes, okay. I think that should be.
This is better. Huge. Like my 4K monitor is not helping. Okay, so hosts HTTP socket path. Path.join. I'm literally just looking at the one on the right. I copy this. Yep. Alec HTTP socket. Okay.
Okay.
Cool.
So that'll just give us basically a string to where that file is allocated. Yeah. Like an absolute path.
Yep. Okay. Okay. And then here we have a little bit of code that says if the socket exists, we'll try to remove it. But if not, then any other errors, blah, blah, blah. So basically, this is just like if the update hook runs and we like reestablish connection proxy or whatever, we're going to make sure we delete the old file because it is a Unix socket file.
Yep.
Before we try to create it again. And I think I actually made a helper method for that here. Yeah. Maybe remove old socket. So instead of copying that block of code, I'm just going to put this in here.
Yep.
And pass in our path. Maybe check for an error. And just wrap error. Could not remove socket. Something like that. I'd probably try to make better error messages later. But, okay, where are we? So yeah, we just did all that in about one line. And so now we can actually create like the listener.
Yep.
Right, because that's kind of the whole point. So it's just easy peasy, copy and paste code.
Yep. Golang does all the difficult bits for us again.
Exactly. Oh, notice we have a gRPC. That's not right. We want HTTP. Better error message. So we're just going to hold on to that listener for just a second. Yeah, and so we also have this line of code. The socket should be usable by all users, blah, blah, blah. Sounds interesting. Let's just copy and paste it.
Yeah, because you don't
but basically,
just want it to be able for root users. Like if the task is running as something else, should still work.
Yep. And this is all inside the namespace of the thing, so it's not like a security vulnerability. Okay, so we've got this file. We've got a little listener. We've changed the permissions. Now we can actually run the proxy, right? And so this proxy method is something that we can just reuse entirely.
Because there's nothing specific there. It just talks about sockets.
This is just a very generic, give me a destination, give me something to point to, and literally
accept incoming connections.
So accept, and then we kind of invoke this proxy con method, which is all very interesting. But if we boil down to the nuts and bolts, it's this. It's literally an io.copy between a destination and a connection.
So it's just copying bytes from one to the other and forwarding it.
Yep, that's all this is doing.
All right, so that should work no matter if it's gRPC, HTTP.
Protocol. It's like a layer below the protocol. It doesn't care.
Yeah,
right.
It's just
and it goes in. It goes in both directions. This is not true. So this one is for socket to console. This one is for console to socket. It's also just doing io.copy, just in the reverse direction.
Yeah, so one is incoming traffic, the other one's outgoing.
This response,
Okay.
And so basically we're just going to lean hard on this method down here.
So that's exactly the same. Basically that gofunc that Envoy method was using is exactly what we're going to use.
So we should be able to just literally copy and paste and it should work, right? It's similar down here. once we've run this once,
Yeah.
we go ahead
Don't
and
want to
set
do it
this run
again.
once flag and don't do it again. Yep. Okay.
Okay.
That was easy. We didn't have to do all this, which is great.
Yep.
There is still one more method, the stop method, right? And so once again, just looking at the implementation that's already here for the gRPC version,
Yep.
we want to have this context be canceled on this proxy object.
Yes.
Just like it says here, if the proxy was never run, we don't need to wait for anything to shut down. There's nothing to shut down. And then there's the done channel waiting down here.
And can we reuse that error that we're returning? Because that's also generic, or does that have any specific gRPC messaging in there?
Oh, this error that I'm highlighting, error
Yeah.
socket proxy timeout. Nope, this is just timed out waiting for socket
All right,
proxy
so
to
that's
exit.
generic as well. Nice.
Yep. Okay, and I think that's pretty much it for this alloc runner hook. Oh wait, no, we need to go back and fill in these things.
Right? We need to actually use it.
Yeah.
So this was all the implementation, which we could 90% borrow from the gRPC hooks that the Envoy method has. We just had to rename a lot of things from gRPC to HTTP.
Yep. And truth be told, like there's an argument that I could have done like some kind of abstraction to only have one hook and just like switch on whether it's HTTP or gRPC. Maybe that's the right way to do this, but for today's live coding, just do it the easy way.
Yeah.
Copy.
First, get it working.
Yeah.
Then make it pretty.
Yep. So pre-run. So just like we have over here, it's the exact same thing, right? Run the proxy given this allocation, and then update exactly the same. And post-run. Post-run's, it's the same thing, but it's not running the proxy, it's stopping the proxy.
Yep.
And really the only difference being we kind of don't want to return an error here if the proxy doesn't want to stop happily. We'd rather just let this thing be unhappy, print a log message and just kind of move on with life. Because we don't want to like bubble up an error if someone's trying to stop an allocation. And for some reason, this like little proxy that's going to get like garbage collected anyway just wants to error out for some reason.
And that's different from the gRPC one, I guess, because there you actually have the Envoy proxy listening as well, or?
Well, no, it's the same.
Okay.
Like with the Envoy proxy, like everything's just going to get destroyed, right?
Yeah.
We don't care if we try to stop a listener.
Oh, so that's why you're only logging it as debug and not actually passing the error back up. Okay, I get it.
Okay, so now we have post run with proxy stop. There we go. So that's the alloc runner hook. If we were to run this now, we would get pretty far. And in fact, you could make this work if you just manually set the environment variable or you configured your task. Yeah, you configured your task to know where to look for this socket.
Yes.
Right. But unfortunately, that's kind of hard to do. Well, it's not hard, but you just have to know where that constant is.
So that's basically, you would set the environment variable like you would do in the manual method that you outlined in the issue at the start.
So the problem is you would have to know what this temperature name is, which is dynamically generated.
Yeah.
And so instead of having you like precog, like understand how Nomad's going to come up with this temperature name, we'll just give you the environment variable. And the way we're going to do that is with a task runner hook.
Okay.
And so now I'm going to jump out of presentation mode and switch to this.
So while you switch there, so the hook that we just coded, that gets run once per task group, and then the task runner hook will actually run for each of the tasks individually, and then after the task group one has run, obviously.
Yep.
Okay.
So now we're looking at the Connect Native task runner hook. You can see package task runner. The name of this hook, Connect Native. All of this already existed because like Nomad 2.12 introduced this functionality.
Oh, can you zoom in
So
on the right?
yeah, so the right's not actually useful, I think,
Oh,
at this point.
okay. So let's just
On the
hide that.
left, so
Yeah.
we have this pre-start hook or pre-start interface
Yeah.
that's going to get executed whenever the task, right before the task launches. And in here, we have this request and response parameters. And the response parameter has a field that lets us set environment variables that we want to have injected into the task.
Okay. So
Right?
where
And
do
so
these request and response variables come from?
anywhere,
Okay.
any environment variable we want to set, we can set it here. And in fact, we already make use of that functionality in this hook for setting the Consul TLS environment variables
Okay.
for your Connect Native task.
Yeah.
And so let's just go ahead and jump into because we're going to do something very similar. We may as well just look at something that already exists. This TLS and env function, literally just Consul CA cert, client cert, client key, SSL, verify, all that stuff.
Yeah.
It's literally just setting a map of these environment variables. And there's a little bit of logic in here, deciding whether or not we should say anything.
So this is
But then,
like if you wanted to do this manually, setting all these variables would get you the same result. But this is all happening under the hood
you
by
could
Nomad.
you could sit there and like actually try to set these yourself, or you just let Nomad do it for you.
Which is what I prefer.
What we try to do, yeah. But you can see I'm just creating. So this guy returned the environment variables that we want to set.
Yeah.
I have this little helper method that sets environment variables on this little variable that's accumulating environment variables.
Yeah.
And then this environment is going to be set on the response.env parameter.
Okay.
And then everything in here.
So it's basically merging what the user has said and then what Nomad has said in.
Yeah. Everything on this response field will be merged with all the other hooks if they set stuff.
Okay.
And then that just the union of all that will be injected into the task. Okay, so all we need to do is implement something like TLS env here that's going to set the environment variable in the case that we're using bridge networking. As you can see, I have boilerplate already made for us. And so all we need to do is kind of similar to the alloc runner hook, is detect if we're in bridge mode. And if so, do stuff. So let's do that. So the way we do this is we have an alloc reference on the hook.
So that's exactly the same reference we had before, or?
Well,
the path looks different. So.
Well, the plumbing is different because this is a test runner hook versus a alloc hook. Okay. So there's more digging into this thing that we need to do. But it's the same little cheat here.
Because we basically have to move up a level.
Yeah, exactly.
Because we were in the task group before where the information actually was.
Yeah. Okay, so we're in bridge mode on the only network that's allowed for connect tasks.
Yeah.
Then we're just going to return nil, not do anything. Otherwise, so we only want to set this console HTTP address environment variable if it's not already set.
Okay.
If someone is for some reason having their console cluster configured such they have console, for example, listening on a public port and they want to contact it that way, then it doesn't make sense for us to override them.
No, you just want to, if somebody said it themselves, you want to use that and then do it.
Yep.
Yeah. Makes sense. Because they probably have a very good reason if they wanted it set like that.
So we'll just check to make sure. I could phrase this a little differently. Okay, just return early.
Yeah.
Otherwise, we're just going to return a map of string to string with the environment that we want to append.
And in this case, we only need to append one value, right? Or we only need to set where the socket is living.
Yep. And so this is just going to be a little bit of magic. So we know it's a Unix socket. So the URI type, I guess, is Unix with a bunch of slashes.
Yep.
And then we're going to go reach back to our alector package that knows where the stuff is predefined, and we're just going to give it
that was the variable that you defined in the other file.
Yeah.
Which we have on the right.
Yep.
Okay.
All right. Perfect. And I believe this is all we need to do. Oh no, we need to actually call our method.
Yeah.
Right.
Otherwise, we don't have the environment variable.
Yep. And so this, we should be able to just do union the environment h.bridge environment given the existing.
Basically mirroring what was done before with the TLSenv.
Yeah. Just looking at this and doing the same thing, but with our bridge network.
Okay.
Now, I think we should be good to go.
I don't see any more to do in the code, so.
Yeah. Let's give it a shot and see what happens. So how do we run stuff? Well, I don't remember. So I believe my little helper thing actually recompiles Nomad automatically.
Yeah.
So we should be good to go. So take just a second. Nomad's a big project. It takes a second to compile.
And you're not compiling the UI with it, are you?
No. Just do plain old go install.
So that's fairly quick still.
Yeah. So now, if we run our cmbridge.nomad job, it's running. Oops, nomad job status and bridge. All right, we got our Alex. They're healthy.
Yeah.
So let's
we had that before. So.
Oh yeah, that's true. Nomad Alex status. Let's look at the front end. 9800 to get our IP address here. Let's try this.
Oh, you need to remove the arrow.
Yeah. Computers are hard now.
I know.
Hey, and it works.
Nice.
Ta-da. That was fun.
So now we have safe Connect Native integration with bridge networking.
Yep. And so just to kind of emphasize what's happening here, we can take a look at this, the actual logs of the task and see what's kind of happening.
Yep.
So if we look at the front end, 33, you can see this environment variable is now set to this special Unix socket that we created.
Yep.
Right. And so it is able to connect to Consul over here. And if I had less logging,
that's so it can actually get its identity when it starts up.
It is asking Consul for its own identity.
Well, and whenever getting the other endpoint, it tried to get that as well via Consul, right?
Yep. So it uses Consul DNS through Consul, the HTTP endpoint, to get the other service. And all that magical plumbing is just automatic.
That's cool.
Yeah.
So thinking further, right? Mounting the Consul socket in like this could also give every other service basically Consul DNS for free as well, right? Just talking with the Consul socket.
That's a good question, actually. I don't know the answer. I've never tried that.
Because I think every service should, if you set that environment variable and you mounted the socket in every task, they could be using x.service.consul to resolve things this way, which is pretty neat.
Yeah, that might work. And give that a try. And if not, we'll bring it up in console office hours.
Yeah, very cool.
All right,
Well,
yeah, that's the extent of my live coding demo.
nicely
I
timed
think.
as well. Like we went
Oh yeah,
5
perfect.
over, but
Yeah,
that's probably due to some of the banter. But
yeah,
thank you for showing this. This is very cool and nice to see that things that feel very magical don't have to be like very
yeah,
scary in code.
yeah, yeah. Uh, it's just a matter of kind of defining what the problem is, and all the components need to be connected together and connecting them.
Yeah. All right. Well, thanks everybody for joining in. Thank you, Seth, for showing us around and well,
Yeah,
daring to
thanks
live
for having
code.
me. This was fun. I've never done live coding before. That's
Let's do
interesting.
it again sometime when you implement the next part of the
The
Connect integration.
ingress and terminating gateways are next. Yep.
Oh, I'd love to see that being coded live. So if you dare to do
That'd be a
that,
very long live stream.
I imagine. So
All right.
thank you. And yeah, hope to see everybody on the next episode of Nomad Under the Hood. So see you then. Bye.